I'm Aki Martinson, and this is an X-Carve CNC router, for which I paid nothing. Let's find out if I got a good deal or not. Right, I did not put this machine together. I've just set it up on the garage floor to see if it works, and I've made a few parts with it just to find out what the problems are, and there are several. The y-axes weren't parallel to the base framework or to each other. I attempted to correct that with this stack here. This is the early model of the X-Carve with the two-piece X-axis rail. They aren't necessarily parallel, and the whole thing is not rigid enough to resist twisting. It needs tramming. I've made some adjustments and tried surfacing this MDF wasteboard with a wide flattening bit, but it's clear the Z-axis isn't perfectly normal to the XY plane. The wiring is a mess, way longer than it needs to be, and with some non-ideal choices for wire gauge and other problems also. Perhaps worst of all, the combination of uneven garage floor and MDF slab that I'm using to support the X-Carve is not even close to flat and stable, as I shall now demonstrate. For that reason, and also because I'm sick of hunching over on the ground working on this thing, my first step is to build a stable, rigid, and flat table for it. A very popular type of tabletop for CNC routers is called a torsion box. To build one, use sheet goods like plywood or MDF to create a network of ribs. One sheet of the same stuff goes underneath and one goes on top. The end result is a mostly hollow but reinforced box. It's similar to a honeycomb or to the way airplane wings are made. It's relatively light and rigid, perfect for this application. This is 1/2-inch MDF. There was only one full-size panel of this available at my local big box store, and it is a little damaged along two edges, so I got it for 20% off. I have to cut around the damage with the result that this torsion box is going to end up 47 rather than 48 inches square. I hope I don't regret that. For the network of ribs, I bought two more pieces of 1/2-inch MDF, each 2 by 4 feet. I'm cutting these into 3.5-inch wide strips. I don't have a proper miter saw station. That's another show. This is more of a job site setup. But you still can, and should, use a stop block to make the length repeatable. With all parts cut to size, it's time to assemble the torsion box. Which brings up a problem. If you don't already have a flat surface to build it on, and the floor certainly doesn't count, how can the box end up flat? What options do I have? This is a granite surface plate. The top of this is flat to within 1/10,000th of an inch. It is the flattest thing that I own. But it is much too small to build a torsion box on top of. If only I had a larger slab of granite. In fact, I do. This kitchen island is almost 4 feet wide and over 4 feet long. Now, it's not as flat as the surface plate, but it is probably the flattest 4 feet by 4 feet in the house. We will build the torsion box in the kitchen. Why, yes, I am unmarried. How did you know? I'm going to glue and nail this together. I have 3 air-powered options, an 18-gauge brad nailer, a 23-gauge pin nailer, and a stapler. The only staples I have are 1/2-inch length, and I want to get started right away, so that's out. Although in retrospect, it might have been the right option with longer staples. My first thought was that the 18-gauge nail might split such thin material, so I'm trying the pin nailer. I don't like these odds. I swear I did test this first on scrap, but I guess I got lucky then. So let's go to the 18-gauge option. Not too bad. Now, I'm building this for a CNC router, and that router will have a spoil board, and I will use the router itself with the surfacing bit to flatten out that spoil board. So ultimate flatness isn't actually that important with this torsion box, the way it would be if I was building an assembly table. More important are stiffness and stability, so that once I've flattened it, it doesn't change too much. Full disclosure, this is far from square, but squareness, like flatness, isn't actually all that critical here as long as I pay attention to it later when I'm fixing the CNC router to the table, and don't use the table edges as any kind of reference. Yeah. I'm checking all around to make sure the top is proud of the sides at every point. Then I'll use the trim router later to remove the extra. More full disclosure, I missed on 3 nails that emerged from the MDF a bit, but only 3 is not too bad. Now we do all of that again to attach the other skin, and any nails I miss this time will just have to be a secret, even from myself. Not bad at all. I know I said ultimate flatness isn't critical, but it is gratifying. Now to the garage for the messy bit. First I trimmed the edges using my router, which happens to be another DeWalt 611 like the one that came with the X-Carve. It's a popular model. Next I chamfer all edges with this 45-degree bit. And then I fill all nail holes with wood filler. I'm adding a layer of spray shellac to seal the extremely thirsty MDF before applying the first coat of wipe-on polyurethane. If you don't use something to seal this, it will soak up the poly unevenly and the result will look blotchy and terrible. Ask me how I know. Hint, I finished both sides of the table, but I'm only showing you one. I've thinned this satin wipe-on poly with mineral spirits to make it even thinner, and it's still streaky.
but I'll fix it with more coats and a lot of sanding. This is like satiny glass. I am so pleased. Let's get started on rehabilitating the X-Carve. If you see white speckles over everything, it's because I had an accident with a bottle of car polish. We'll clean that up, and we'll begin by tearing down the machine.
Right, this is the gantry of the X-Carve. I need to take it apart, clean it, and rewire it. To that end, I've brought it into the house and most importantly into the air conditioning. No, my garage is not air conditioned, but I would like it to be. Like, comment, and subscribe.
By the way, I recognize that new X-Carve content probably wasn't on your 2025 bingo card. These machines have been out for a long time. So this video is more about rescuing a neglected tool and making it useful again.
I'm taking the opportunity to thoroughly clean all of these wheels and other mechanical parts. It's not maybe super necessary to do this, but while I'm here, I might as well do it. And anyone who says they'll never be this clean again, part of this is due to the fact that this machine in its previous life did not have the best dust collection. More on that later.
Now that everything's clean, I can reassemble the two gantry plates. By the way, I'm following official instructions from Inventables for the reassembly. There's nothing remarkable here. The carriage and Z-axis are of course also filthy, so they get the same treatment. Once again, I clean everything and put it back together. I'm lubricating the lead screw with white lithium grease. And that's the carriage and Z-axis reassembled. At this point, I put the carriage back on the X-axis rails and adjusted the V wheels for smooth operation. It's important to adjust these eccentric wheels so the carriage moves easily, but with a minimum of up and down play. About that two-piece x-axis. There are many modifications that people have made to tie the two rails together, but one of the easiest is Matt Wheeler's 30-minute x-axis mod. Link in the description. All you do is insert some machine screws through the gap with washers on either side and use a nut on the bottom to clamp them together. It's quick and dirty, but some users report that it's pretty successful, so let's give it a try. I found that I couldn't quite insert M5 through the gap, so I used M4. These are also a little too long. 5 mm shorter would have been ideal. But the carriage passes by just fine, and I'm not sure how well this will work in the first place, so we'll go with it for now. And now for this mess. It's time to take the cable guide apart and rewire everything. I'm going to try connectorizing the limit switches. I don't know if this is a good idea, but it's annoying that you have to remove the switches from the machine to disconnect the wiring harness and cable guide. I will use these JST style crimp pins and housings. They are cheap, no-name products from Amazon, and so is my crimp tool. I wouldn't recommend either for important or safety-critical applications. I added connectors to all 3 limit switches, so now I can continue with reassembly. The stepper motors get wired to terminal strips on the gantry plates and on the carriage. I have some wiring to do. First, I have to add male ends to these black and white wires so that they can hook up with the limit switches that I previously connectorized. Then there's this. In between the 2 cable guides is located the ferrite for this. Now, I probably want this closer to the motor, electrically. There may have been, I guess, a mechanical reason that they put it here, but I'm going to move it here anyway. I think it'll be okay. First, I'm breaking down this splice in the router's power lead. Since ground isn't carried through, we'll splice on a new 2-wire cable later. Now I'm adding the complementary male connectors to the 3 pairs of wires that lead to the limit switches. This cable guide isn't the kind where the segments have snap-on covers. Instead, I have to fish everything through from one end. Right. Now what? I just realized that I made a big mistake. I forgot to add the x-axis belt, which means I have to take all of this apart
and reassemble it. So I guess I'll just do that then.
Now to figure out how to connect to the controller.
This is the original first generation X-Carve controller. It has a G shield on top of an Arduino Uno. The limit switches connect to this header down here, and I just realized that it is a male header, and I crimped male pins onto the wiring harness. So I'm going to have to cut these off and redo them with female pins. All right, that done, we have to insert these into this 8-pin housing, but we need to know where to insert each wire, which means we need to know which limit switch it's connected to. For that, we will use this multimeter in continuity mode. So that is Z-axis.
As with the limit switches, we need to figure out which cable goes to which stepper motor. You can short out the green and black wires, and the corresponding motor will resist turning by hand. That way we can get the 3 cables labeled and connected to the controller. That's all the connections done. We can test much of the function of the X-Carve with just the gantry. We don't need the Y-axis rails or the base framework.
Hey. Nice.
All the motors and limit switches are attached to this part of the machine, so from the controller's point of view, everything is present.
Oops.
What just happened here?
My apologies for this out of focus shot, but it's the only one I've got showing what happened. The limit switch is upside down, so the roller won't make contact with the screw head. I have to take it off and install it right side up. But how? Look at this. The 2 holes for the limit switch are clearance holes rather than tapped. That is absolutely criminal. How am I supposed to get this back on there? Obviously I put it on when the carriage is off of the gantry. Now I'm faced with the choice of either disassembling everything to put the nuts back on the other side of the screw, or trying to fiddle around in this space here, but you can't get a finger back here. Maybe I can make something happen with pliers, I don't know, but it's a pain. Some of the other limit switch holes are tapped, weirdly enough, but not these. And I think they did probably fix this in later generations, but there's a lesson here in how to design a product for maintainability.
If you're wondering why I didn't just tap the holes myself, it's because they're already drilled to clearance size, and the next size of screw, which is 440, would be too big to go through the limit switch housing.
And there we have it.
Of course, having it right side up doesn't guarantee a good result, as this comedy of errors shows pretty clearly. Off camera I bent it a little and adjusted the placement, and now it's working reliably. I've broken down the base framework and cleaned it. Now I'll put it back together. This original spoil board has absorbed moisture and swollen at the bottom edge, so it's far from any kind of flat surface, which I spent a lot of effort trying to achieve with the torsion box. So why use it here? I'm only trying to use the mounting holes to establish the general layout of the base framework. At some point I'm going to replace the spoil board anyway. I probably won't need whatever that was. I'm using this clamp to make sure the right angle joints at the corners are tight. Now, let's bring it back out to the garage and set everything up on the torsion box table. Look at this gap. Because I paid a lot of attention to getting the corner brackets very tight and therefore repeatable, the overall stack up is a bit short. But I can make it up by putting a washer under the bracket on both sides. I repeat this on the other end and on the other side. I'll attach the machine firmly to the table later. I have decisions to make about where exactly to screw it down, and I'd like to get it up and running provisionally first, which might inform those decisions. For now, I'll just clamp the controller and power supply to the table. Okay, I've set up a temporary command center here to test this out. By the way, it is raining and it is the 4th of July, if you hear any noise or explosions. Guess what? I had the Y-axis limit switch upside down as well, but at least these holes are tapped. And that's how it's supposed to work. Here's a quick and dirty 3D printed Sharpie adapter. It's not great, it needs some compliance. I should add spring loading so the pen tip isn't jammed against the workpiece. But it'll do for this test. These circles came out very well. There's a little bobble at the start and stop, but that's probably because the felt tip got crushed a bit and started dragging. There's certainly a lot of tweaking to be done before I can actually use the router, but that's for another day. And that's a pretty good place to stop for now. If you're still with me, thank you. You must really like this topic, in which case you should definitely subscribe. In the next video of this series, we will calibrate the machine, continue upgrading it with further stiffening modifications,
And we'll build a pretty great dust collection system. You won't want to miss that. Martinson, and this is X-Carve CNC Router, for which I paid nothing. Let's find out if I got a good deal